Does time really exist, or is it merely a human construct? A question that has been tugging at the minds of thinkers, philosophers, and scientists for centuries. Time as we know it seems straightforward. Seconds turn into minutes, minutes into hours, days into weeks, and so on. But is this progression of time a fundamental truth of our universe, or just an illusion? Let's take a detour into the realm of philosophy. The ancient Greeks had two words for time: chronos, which refers to sequential time, and kairos, signifying a moment of indeterminate time in which something special happens. So, is time a sequence or a moment, or is it both? The philosophical perspective of time is as layered and complex as the fabric of reality itself. Now let's venture into the world of science. The laws of physics, as we understand them, don't differentiate between past, present, and future. The equations work the same whether time moves forwards or backwards. Isn't that a head-scratcher? Let's consider the theory of relativity, proposed by Albert Einstein. His groundbreaking work suggests that time is not absolute, but relative, and it can stretch or shrink depending on the observer's speed and gravity. So if you're moving faster or are in a stronger gravitational field, time slows down for you. This is not science fiction, it's science fact. Then, there are quantum physicists who propose that time is not fundamental, but emerges from other, more basic phenomena. Some even argue that time is an illusion, a human construct developed to make sense of our experiences. So, what's the truth? Is time an illusion or a relative entity? Or is it something else entirely that we are yet to understand? Theories abound, and while we may not have a definitive answer, the exploration of this concept continues to fascinate us. So are we living in a timeless universe? Let's dive deeper. The journey through the unseen reality of time is just beginning. Hold on to your seats as we delve into the mysteries of the cosmos. Is the universe infinite? What do you think? The idea that the universe may be infinite is a concept that defies our understanding of space. It's like trying to imagine a never-ending story, except this story is written in stars, galaxies, and cosmic dust. It's a concept so vast and so mind-boggling that it pushes the boundaries of our imagination. When we gaze into the night sky, we're seeing a tiny, tiny fraction of the universe. Even with our most advanced telescopes, we can only observe a small part of the cosmos. It's like trying to understand the entirety of Earth while peering through a keyhole. So, how do we know the universe might be infinite? Well, we don't know for certain, but there are theories backed by some pretty impressive mathematics that suggest it's a possibility. One of these theories is the concept of the flat universe. According to this theory, if you were to travel in a straight line through the cosmos, you would never return to your starting point. Instead, you would continue on forever into an endless expanse of space. But it's not just theoretical physicists who think the universe might be infinite. Astronomers have also found clues in the cosmic microwave background radiation, the afterglow of the Big Bang. This radiation is remarkably uniform, suggesting that the universe extends far beyond what we can see. Yet, the idea of an infinite universe raises some puzzling questions. If the universe is infinite, then there must be an infinite number of galaxies, stars, and even planets just like Earth. This leads to the concept of the multiverse, a theory that there are an infinite number of universes, each one unique, each one teeming with its own set of cosmic wonders. In the end, the question of whether the universe is infinite is one that might never be answered definitively. But isn't that what makes it so fascinating? The universe in all its vastness remains a mystery, a cosmic puzzle waiting to be solved. If the universe is infinite, then what's beyond it? Did you know that your brain might be a mini-universe? Intriguing, isn't it? But let's delve into this. The human brain, a complex marvel of nature, is often compared to the universe, not just metaphorically but also structurally. That's right, your brain, that 3-pound mass of jelly inside your skull, could very well be a miniature universe. Consider this. Our universe is a vast, seemingly infinite expanse of galaxies, each harboring billions of stars. Now let's scale down to the human brain. It's composed of approximately 100 billion neurons, the fundamental units of the brain and nervous system. These neurons, akin to the stars in a galaxy, form intricate networks, or neural galaxies, if you will. Each neuron in your brain can connect to up to 10,000 other neurons, passing signals to each other via as many as 1,000 trillion synaptic connections, more than the number of stars in a galaxy. This complex interconnectedness mirrors the vast network of galaxies in our universe. But it doesn't stop there. This similarity extends even to their respective structures. A recent study revealed that the network of galaxies in the universe and the network of neurons in the human brain have strikingly similar structures. Both networks display a remarkably comparable level of complexity and self-organization, suggesting an underlying universality of how networks, big or small, might be structured. This mind-boggling comparison leads us down an existential rabbit hole. If our brains are like mini-universes, could each thought, each spark of electricity, each neural starburst be akin to cosmic events happening billions of light years away? Could each memory or dream be a constellation within our neural galaxy? This theory may sound like a wild flight of fantasy, but it's grounded in real scientific observations. And while we're far from understanding the full implications of this cosmic connection, one can't help but marvel at the thought. So, could we be holding an entire universe within our skulls? What if I told you particles can be in two places at once? Now, before you dismiss this as pure science fiction, let's dive into the fascinating realm of quantum physics. Is the world where particles defy our conventional understanding of reality? First, let's talk about the principle of superposition. In the quantum realm, particles don't exist in one state or another, but all possible states at once. Yes, you heard right. A particle can be here, there, and everywhere. Only when we decide to measure it, to pin it down, that it chooses one state. This is like flipping a coin, which is both heads and tails mid-air, but the moment it lands, it chooses to be one or the other. Let's move on to the concept of quantum entanglement. Two particles that become entangled, meaning that their states are linked. No matter how far apart they are, a change in one will instantly affect the other. This might sound like magic or some sort of teleportation, but it's real. It's a phenomenon that Einstein famously referred to as spooky action at a distance. Implications of these quantum quirks are mind-boggling. They challenge our understanding of the universe and how we perceive reality. They open the door to the world of teleportation and faster-than-light communication. They even force us to question if we really know what it means to be in a specific place at a specific time. Yet these aren't just theoretical musings. Quantum mechanics is the backbone of modern technologies like lasers and semiconductors, the driving force behind the development of quantum computers, which promise to revolutionize computing. So, as we grapple with these strange quantum realities, we must remember that the universe is far more complex and enchanting than our human minds can fully comprehend. Particles can do this. What does it mean for our understanding of reality? Perhaps it's time to embrace the strange, the unexplainable, the quantum. After all, the universe is stranger than fiction. Could all these mind-boggling facts be interconnected in some way? Our exploration of the unseen reality of time, the infinite universe, the universe within, and phenomena stranger than fiction leads us to ponder this question. You see, scientists have long dreamt of a grand unifying theory, a theory of everything, if you will. A theory that could reconcile the seemingly contradictory principles of the macrocosm, the universe with its galaxies, stars, and planets, and the microcosm, the peculiar world of quantum physics, where particles can be in two places at once and can even pop in and out of existence. The concept is mind-blowing, isn't it? A single, unified theory that could explain everything. From the expansion of the universe to the behavior of subatomic particles. A theory that could potentially elucidate the mysteries of dark matter, black holes, and even the origins of the universe itself. Imagine standing on a beach, with the vast ocean representing the cosmos, and the grains of sand beneath your feet symbolizing the quantum world. Now, imagine a theory that could describe both the ebb and flow of the ocean tides and the intricate patterns of the grains of sand. That's the kind of comprehensive understanding a theory of everything could potentially provide. However, despite the best efforts of some of the most brilliant minds in history, this elusive theory of everything remains just that, elusive. The complexities of the universe and the paradoxes of quantum physics continue to baffle scientists, leaving us with more questions than answers. Perhaps the most mind-boggling fact is that we've only just begun to scratch the surface of understanding our universe. As we continue to delve into these mysteries, who knows what astonishing discoveries await us? If you enjoyed this journey into the unknown, remember to like, subscribe, and stay curious.